Yeah, this Kafka here that you can see at the top pod is.
That's just development.
Yeah, it's development. Oh, sorry. I know we are running Kafka on VMs.
So I was hoping for a bit stateful sets, but
Sorry.
I was hoping perhaps a bit stateful sets on Kafka Kubernetes, but
No, not quite.
okay. So are there any plans to move Kafka production to Kubernetes or?
Not at this stage, no. We see Kafka as something that holds quite a lot of state, and things we want to do in Kubernetes shouldn't really be holding their own state. So we don't have persistent storage at the moment in Kubernetes. So.
Okay, I'm back to why you say Kubernetes shouldn't hold state, because that's what stateful sets bring.
Okay.
But
yeah, at the moment we're not using it for our heavy applications.
You still need to back those states up to something.
True.
Yeah.
So S3 or whatever, and currently we
you can use EBS for I don't know where you're running, but
yeah, we could, but in general, like we currently use Kubernetes as something that quickly spins up stateless containers, and obviously there's ways to also run stateful databases or whatever you want in Kubernetes.
It's only better in one or twice. So.
Yeah, exactly. We might use that in the future, and definitely for things like GitLab itself or a lot of other components, it might make a lot of sense. But for Kafka currently, we decided to just keep the Kafka cluster stateful on a VM and just run everything around Kafka, the whole topology around Kafka as containers in Kubernetes. Yeah. But obviously you can. There's no reason technically why you couldn't.
No, I'm just curious. And you're also running on what's the runtime environment? Or is it on data center or a specific cloud provider where you're running?
You mean the Kubernetes cluster itself? Schubert. Well, I work for Schubert Phyllis, and we run it in CloudStack in this case. But we could have just as easily spun a cluster up in AWS or Google Container Engine.
Let's keep it for quick.
Yeah.
Can use that all. This is running on a div cluster. So.
What's happening, John? Is it just slow?
It's slow like it was this afternoon, but it's also not very happy.
Were you by any chance running Kafka on the cluster as well this afternoon?
No, we kept the same space.
Okay.
So, what I'm trying to do here is log into the Twitter source connectors. There's a number of command line tools that I can use to. Hey, there we go. So, this is me listening to the first topic. Maybe Trump's just talking too much.
Are these the Trump's tweets or are these tweets?
These are Trumps with the word. Sorry, these are tweets with the word Trump in them.
Because this is on the 1% chance as well.
Yeah. Lots of useful things to say. So this is me getting a live feed of. I think it depends which route I go through.
Yeah.
One of you.
Yes.
This is not actually our cluster itself, as you can see it's running. It's connecting to it from here. Which sometimes is happy, sometimes. So, cool. So these are the three topics we've got in our original diagram. Which way? Where's it going? This diagram tweets, counts, and short tweets. Top tweets, middle counts, short tweets. Now, let's say we decide that we find there's too much stuff coming through and we want to change our topology. So, if we want to alter the topology, so add a node, relevance filter, which we are going to say is we'll only pick up tweets from people who have enough followers. We want to modify our topology. We can do this with another branch. So if I look at the diff here, this is a diff between what's currently running and what we want to do. We want to put in another node called relevance filter. same process. I connect that apparently. Make a merge request. Get the same pipeline. This time it's going to be different. We're not starting from scratch. We're making an update. So now you see the applied desired state. I have to, sorry, when this branch was created, this pipeline was run. When the branch was created, we had nothing in the real world. We still had that one branch that was yet to be applied. So if I retry this build,
It's probably going to be slow as well.
hit and miss. No one happens before you can actually get to the page. So it's running a GitLab island and it needs to go and get to the Kubernetes cluster.
Quick question in between.
Sure.
Who maintains Helm?
I believe it's the guys from Kubernetes.
No, yeah, it's Google. So basically, Kubernetes was Helm was a community project by the guys that do. I don't remember the name, but basically the package manager inside that project, sorry. The package manager inside it was actually really good. And so Google or Kubernetes, the guys from Kubernetes said, hey, we're going to make that the official package manager for Kubernetes. So since 2 months and since the official release 1.0 of Helm, it's a Google maintained project.
Every new release, we have to release it once or
No, it's independent of the releases of Kubernetes, but yeah, it's just they're releasing regularly, and since a month it's actually usable in production. But we're cool guys, so we try to use it as quickly.
Yeah, but I think your question also, who manages the updates of Helm and Tiller in the cluster. So of course you have a new release of Helm, just like many other add-ons of Kubernetes. Who manages that? Is that the Kubernetes management team or?
You mean who updates the tiller in the
Yes.
the Helm tiller? Yeah, that's me. Well, yeah, that's the maintenance team. No, but I mean it's just a matter of redeploying the deployment in Kubernetes of the.
Yeah, I know it's very easy, but it's a responsibility for someone.
Yeah. Well, that's me.
Okay.
Yeah.
Yeah, so it's placed at the operations team of the platform.
Yeah, I mean, to be honest, our team, especially since the introduction of Kubernetes, we don't really have a division of operations and development that much, and it's. I mean, I can actually say that we've been doing quite DevOpsy approach to this. So anyone, I
Let
think,
me rephrase. It's the platform team and not the application team which builds the policies upon.
in our case, that's the same.
Oh, that's
team.
also the same. Okay.
But
So
yeah,
it's a very small team at the moment.
well, I mean, no, it's the platform team. Sorry, yeah, and there's other people building topologies with these two. Yeah, sorry, platform team. But we also build topologies. So.
We've had some responses from the cluster, so we'll keep moving on. What I've done here is I've opened up another reader, and I'm actually reading that extra topic that we want to insert between tweets and the count tweets, short tweets. There's nothing in there yet because the topic doesn't actually exist. The landscaper is telling us in the test run, if you focus here, we're going to create a new one, that's a new node, and we're going to update a single node, and you get a diff of what's going to happen. So here with a small diff on the update is that the input topic has changed. So we can come back to our merge requests, we have confidence that this will be successful when we can actually access the cluster. This pipeline. This is running, hopefully a little faster this time. Yeah, oh. So if I find my process will start running tweets. Hey. So
Yeah.
our other node is live. We've got raw tweets at the top. We've got tweets filtered on people who have no followers. We're now counting the words in those tweets only and selecting ones that have 10 words. It's a little hard to see, so I will change the command. Put it in control channel.
Kafka on Kubernetes is not very stable in general.
Yeah, not at the moment.
Can I ask a question? Is there a way, I don't know very well Kubernetes, is there a way that you can start Zookeeper, make sure that Zookeeper is up and running, and only when that is came, then you start the brokers, and only when the brokers are up and running, then you start the Kafka Connect framework on the stuff. Is there a way that you can do these checks and dependency and wait
No.
for the service to start?
No, basically the way that Google does these types of things and does Kubernetes do these type of things. Basically, we start everything up in the same time. You can do orchestrated deploys, right? So first do the database, then do the application, and then do Kafka, and so on and so on. But basically, with containers and Kubernetes container orchestration, the idea is we just fire up everything, and Zookeeper is not up yet. So if you start Kafka, it will probably error out at some point. Because the Kubernetes as an orchestration platform has health checks and liveliness checks of your containers. It sees, hey, Kafka failed, so it just kills the container and restarts it up again. And it has a backoff time, and so it basically it tries longer and longer. But at some point, everything gets stable, and that's basically how the ideology behind Kubernetes. So are there ways to do it? Yeah, but then you would have to write some own scheduling mechanism, and that kind of defeats the whole purpose of something like Kubernetes. So
Yeah, you use Eneco Energy Trade.
Have this built in. I think they have a series of checks within the Confluent Docker to make sure that Zookeeper's open before they try and start. Don't they?
Yeah, the Confluent Dockers do have some.
and the other thing why Kafka and Kubernetes are not such a great fit currently is because Kafka does its own service discovery through something like a Zookeeper. So if a consumer connects to Kafka, it basically says, hey, give me a broker that I should connect to, and then Kafka gives a URL back or an IP back that the consumer needs to connect to, and this type of mentality doesn't fit in very great.
You have stateful sets as so if you have stateful sets, which were best set before, then each bot will get its own DNS entry.
Yeah, exactly.
So
That's the way we solve it as well now with our having it outside Kafka running as VMs. Obviously, that is a different network, so it's giving internal DNS names, and we add those DNS records to each node and with a stateful set. But so you can work around all these things, but
There's a way, I managed to do it with someone from Red Hat on OpenShift to do a dynamic service discovery. So every time you spin up a new broker, you see where it's running, what is host name, and then it's registered in Zookeeper also properly. But it's really a POC, but no production state.
So we finally got contact key. This is the filter just down to the field of followers count, and you can see that filter is active. Top, we're getting lots of tweets from people who nobody listens to, and then we filter it down to a few less tweets, and then now the rest of that pipeline works. The final thing we wanted to do to show as another change, if I've got another line, is to say at the moment the relevant followers threshold 1,000. If we want to make that 10,000 because we're still getting 20 tweets, we have yet another branch which we can have a look at. It's quite simply the alpha factor for the filter. Replace 1,000 with 10,000. Merge request. Again, you see that pipeline is running on something that is created after we deploy this. You get a small update, you can see what's going to happen. If I merge that, and quickly comes in here, you should see it change from being only things above 2,000.
It's fine, John.
We do the charts, right? And then we start attaching metrics back to our graph, start building pretty pictures for the operational guys to see the form. We also get isolation as well, because there's another thing about going into Kubernetes was before we were running VM, and we had all our connectors in VM. But what happens if taking down, following the trunk takes down another critical flow as well? So you want to do separation concerns as well.
So you have, if you're using the Spring framework, you have, for instance, you have Spring Cloud Data Flow, which is also a framework which does this kind of thing. Have you looked at it? Or have you looked at other, the downside is, of course, you have to run some Spring applications.
Well, we use Spring, I'm going to get this wrong, boot, it was called.
Yes, Spring Boot, yes.
We use that as a chassis within the, to wrap all our Java code for the processes in there.
Yeah, and have you looked at Spring Cloud Data Flow?
No.
I took a look into this, and I think the problem with, I mean, I don't have a lot of experience with this, but because the ecosystems are moving so fast, and Spring, I think it's slow to adapt to all this. But then maybe you have more experience with it.
As was mentioned in an earlier presentation, obviously to do these topologies, there's tons of different ways. You can use WAR, or you can use Chef or Ansible or Puppet, or you can use Mesos, and I mean, there's no right answer.
No, of course, but I'm just curious about which trade-offs you've chosen, and why to build it yourself and not choose something that's already available, perhaps in a bit early state. But
Well, the thing is, nothing what we showed here we built ourselves, except for a tiny little piece of code that basically does a diff between some configuration files and Kubernetes, and then applies those changes. So in terms of building it ourselves, it's just, in the end, it's just a set of technologies that you use together. And in our case, it's Kubernetes, Kafka, the Cloudera stack, and together, all the components, the connectors, the processors, we decided to run in Kubernetes. But yeah, it's not really building it yourself. In the end, it's just taking a set of technologies and combining them.
It's a difference.
It's taking all the components of Kubernetes and deploying it as a service.
For us, the reason to use Kubernetes is because it's just an awesome way to scale. And
It's not built by Eneco. It's built by Schubert Philips, which are mission critical platform providers. So stabilizing this is their responsibility. Like was mentioned, you shouldn't be doing this when you're an enterprise, because the IT skills you need for this are way too heavy to get it operationalized. Because they have a mission critical platform team that can help us with getting this stable. So it's a choice you're making between the cool and the not so cool. We went for Kubernetes also because they could deliver it to us.
Yeah, but Spring Cloud Data Flow actually deploys onto Kubernetes, but
you can, I mean,
I was just curious about some trade-offs, but
So maybe we should
Wrap it up, I think. Yeah, so that's what we were trying to achieve, and we were almost there. Some connectivity problems, always the bane of demo. There's a little nugget about how the deployment works. So we're basically executing a piece of Lua code in the middle of the stream processing framework. This is some Lua to get the alpha parameter and then return boolean based on a field in the tweet. The components we use to run this